Lesson 1.4, perform basic matrix operations, which is the same as lesson 12.1 out of your textbook. So the slides for the rest of the video will say 12.1. No matter what you might think, the movie The Matrix is not really a matrix as far as math is concerned. Matrices are simply a way to organize data. For example, a computer desktop wallpaper, which is known as a bitmap, is a matrix. Each little point is a pixel, and there's a number that represents the color of that pixel. And so you end up with a whole array of numbers, maybe 2, 5, 5, 1, 3, 2, 0, 0, 2, 5, 5, and it'll continue, and you get all these numbers arranged like that. A matrix is a rectangular arrangement of things, like variables or numbers, something like that. See, it's shaped like a rectangle. The elements are put into rows and columns. Horizontal are rows. Vertical are columns. So there's rows and columns. Columns go up and down, just like in a building. The things that go up and down that hold up the roof are called columns. The dimensions of the matrix is the number of rows by columns. So how many rows do we have? We have 1, 2, 3 rows by 1, 2, 3, 4 columns. So this is a 3 by 4 matrix. In order for two matrices to be equal, they must have the same dimensions and corresponding elements must be the same. For example, these two matrices are equal because the 1s are in the same place, the 2s are in the same place, the 3s are in the same place, and the 4s are in the same place. They're exactly the same. So, find the value of these variables. Well, if we start with x, we'll have x divided by 3 is the same as 5. So x would be 15. If we look at y, y is in the top right. It equals the top right. So y plus 1 equals negative 4. So y would be negative 5. The w is in the top left. It would equal the top left. So w is 2. And lastly, the z is the bottom right. And so it'll equal the bottom right. So z would be 8. You can add and subtract matrices only if they are the same dimensions. When you add or subtract, you simply add or subtract the corresponding elements. For example, I would add the top left with the top left. So 1 plus negative 2 is negative 1. Top right with the top right, 2 plus 5 is 7. The bottom left with the bottom left, negative 5 plus 4 is negative 1. And the bottom right with the bottom right, 4 plus a negative 3 is 1. Let's try a couple more examples. Well, here's several. So we're going to add the these are just 1 by 2 matrices, 1 row, 2 columns. They're each 1 row and 2 columns, so we can add these. So I'll add the left with the left with the left. So I'll have 2 minus 3. 2 minus 3 is negative 1, plus 1 is 0. And then the right-hand ones, I'll have negative 3 Minus 4 is negative 7, plus 0 is negative 7. Let's try this one. This one looks a little funny. They don't look the same, do they? This first one is 2 rows and 2 columns. Second one is 2 rows but 3 columns. Since the dimensions are not the same, it is not possible to add or subtract them because they have different dimensions. The last type of matrix operation we're doing today is scalar multiplication. A scalar is just a single number, meaning it's different than a matrix. It's just a number. And so we're multiplying each element by that scalar. So it's essentially the distributive property. So 3 times this matrix. The 3 here is the scalar. All you do is you distribute it. So you'll have 3 times 5. 3 times negative 2. 3 times 7. 3 times negative 3. 3 times 8, and 3 times 4. And that's all there is to it. The National Weather Service keeps track of weather. Here are data from June and July 2014 for Benton Harbor and South Bend, showing the days with precipitation, the clear days, and the days with above normal temperatures. We could write these as matrices if I just put brackets like that. So that would be one matrix, and that would be the other matrix. What would be the meaning of the first matrix plus the second matrix? Well, if each one is the number of those days in June and then in July, when I add them together, it would be the combined June and July. So it would be the total number of days of each type for each city for June and July combined. So, find the total weather stats of each city. So we are going to add these. So I'll have the 13, 18, 16, 13, 12, 19. So that's the first one. That's June. I'm going to add the July. All right, so 13 and 14 would be 27. 18 and 15 is 33. 16 and 18 is 34. 13 and 18 is 31. 12 and 2 is 14. And 19 and 8 is 27. So what's that mean? It means Benton Harbor had 27 days of precipitation in June and July. South Bend had 33 days of precipitation. Means Benton Harbor had 34 days of clear, and South Bend only had 31 clear days. Benton Harbor had 14 days that were above normal temperature, but South Bend had 27 above normal temperature days.